Hi everybody. I want to give just a short little presentation about some work that we've been doing with auto-grading student work in our How to Design Programs based course. And the issue here, as everybody knows, is how do you grade the design recipe in a productive way. So I'm going to try to keep this pretty short so that there'll be lots of time for questions. So here we go. As I said, we've got a How to Design Programs based course. We teach about 2,000 students a year in 7 sections with 2 or 3 instructors per term and 40 or 50 TAs per term. So one of our big issues is scale, right? How do we give good design recipe-based feedback at scale? And we'd like to be able to do that on weekly problem sets. We'd like to be able to do that on exams. And going forward, we'd also like to be able to do it in lecture. We'd like students to be able to work during lecture and get good feedback on their work. We do that now by having TAs walk around, but the TAs can't really get down into the aisles. Since we're grading the design recipe, we want to give more than just correctness marks. We want to say things that are specific and focused about method and process and how the students are doing. We also don't want to be too specific. We don't want to sort of say, this is wrong and it should be this. Because we want the students to be able to use the feedback to figure out what's wrong in kind of the same way that they would if a teaching assistant said to them, I'm not sure that your signature is correct. We don't want to say what it should be. We want to say kind of where to look. So how does our approach work? We've got kind of a 3-part system. We've got some metadata annotation, some marks that the students put on the programs to identify recipe elements and declare design rules. And we've got a very little bit of checking of that stuff on the Dr. Racket side. On the server side, we have a simple domain-specific language for writing graders. The grader structure kind of mirrors the program file structure. And we've got some simple composition of grader elements that work in terms of composing scores that build up from individual item scores to the score of the entire submission. And those scores have both a numerical value and comments. And we use the existing Dr. Racket hand-in system with a number of changes and mostly simplifications. So to kind of show you how all this works, I'm going to sort of show 3 things. I'm going to show a small program that a student might write. I'm going to show one of our graders, and I'm going to give you a sense of what the grading reports might be. So here we go. This is taken from our midterm 1. So this was basically in about week 5 of our course. And the first thing you see is this thing at HTD QualComp means the next part of the program follows the how to design data, what we call the how to design data recipe for a type called QualComp. And we've got the type comment. We've kept that exactly as it is in the books. But we put a little bit more emphasis on the systematic production of a template, a 1-argument function for operating on a QualComp. And what we want the students to do is write not just the template, but also the rules that they use to form the template. So, this says, well, there's a one of, and then there's 3 atomic distincts. And we've got, as I said, a little bit of support for working with this in Dr. Racket. Let me just quickly show you that. In the case of this program, what the students can do if they click our templates button, which is kind of like the check syntax button, is they can see a correspondence between the rules that they wrote and the parts of the template that they cover. And we're still working on building this out. But the idea here is to help them learn that, this is a statement of how you produced the template. This is the actual template. And what the grader is going to do is check that it believes that you got the right template corresponding to the rules. So that's part of a simple program. Another part of a simple program would be a function that operates. Here we've got a function that actually is going to produce a QualComp, not consume a QualComp. So again, there's a tag here that says that the next part of the program follows the how to design functions recipe for a function called compare. There's a signature. Here's some check expects. All of this part is directly straight out of the books. we add one thing here, which is this template tag says, well, where did you get the template that you based this function on? And the template for this function is based just on atomic data, or what the way we would describe it is the specific atomic type, which is number. So that's what the student writes. On the server side, this is what we write. I simplified it a little bit for the presentation, but this is, except for some details, is running code on the server side. This says, okay, we're going to grade problem 1. We're going to look for, the next thing we should see is a how to design function recipe for a function that it doesn't matter, we don't care what the name is. Later on we will care, but here we said we didn't care. This says inside of here there's going to be a bunch of items, at least 2, and their relative weights are going to be 20%, 20%, and then divide everything else evenly. This says look for a signature, it better be this. This says look for a template tag, it better be that. This says that the tests they submitted, we're going to run them and make sure they pass. This says we're going to have some additional tests in case they didn't maybe write all the tests we wanted them to write. And this says, what this says is run each of their tests, run each of the students' tests, bind the arguments to A and B, and then try to satisfy these predicates. And it better be the case that by the time you run all the tests, each one of these has been satisfied. So the way to think about this is this says, look, there better be one test in which A is less than B, one test in which A is equal to B, and one test in which A is greater than B. And these are arbitrary expressions. So, you could make them much more complicated in more complicated functions and functions operating on trees, for example. You're going to see some more complicated expressions here in order to satisfy ourselves that they've really used enough test values. We don't, because it's a first year class, we don't, push too hard on that, but we are trying to get them to start right away thinking about sufficiency of test values. So that's what we write on the back end on the server side. Let me just summarize that a little bit by saying there's kind of 3 kinds of primitives in that domain-specific language. There's these grade star primitives that basically grade the current program elements. So HTTF, HTTD, HTTW, problem, signature, template. We have a special one for doing stepping problems. We have another one that checks whether they've preserved a template properly when they used it. Below that, there's a similar level, a level of similar functions that actually operate on program elements as opposed to the current program element. So that lets us do some more complicated teasing part of the program if we want to do that. And then there's, right, every language should have primitives and means of composition. And our means of composition are the weights function that you saw, some other ways of combining scores. We have a thing called score max that lets us, for example, grade something 2 different ways and produce the higher score, and something that lets us scale scores. So that's the server side. Now let's look and see what the students see. So this is a report that a student might get for that program. It says, well, in problem 1, in the how to design function for compare, and I think you can read it as well as I can read it to you, right? The signature was incorrect, the argument types were incorrect, the number of arguments was incorrect. This signature, I took this directly out of the database for our midterm 1 exam. This student did not get the signature very right at all. They didn't have a template tag, but their submitted test pass and our additional test pass, and they had good test values. Let's look at another example of a report a student might get. So here's a student that the signature had incorrect argument types, but the result type was correct, apparently. The template tag included incorrect type origins. So instead of saying something like template number, it said template qualcomp or template string or template something incorrect. And it was missing type origins. It didn't say template number. Here's an example of what I was saying before, which is we're not saying, look, the template tag was supposed to be this. And the reason we're doing that is, in lecture and in problem sets, they're getting this feedback and then they get to try again. We want them to have to figure it out. We're really trying to mimic, to whatever extent we can, the behavior that a good teaching assistant has, where they sort of say, really, does your check expect match your signature? And then they walk off, right? They leave the student to think about it. That's what we're trying to do here. So we're trying to say stuff that's correct, but isn't completely prescriptive. And then we found that for some of these, when they're bad, when they're incorrect, it helps to really explain what additional tests mean. Okay, so when additional test comes up, they get a complete description of it. When submitted test comes up, they get a complete description of it. When test values come up, they get a complete description of kind of how to think about that. As I said, I tried to keep it short. That's kind of all I was going to say, was to kind of, show you the architecture of our system and show you some of the things we could say. I guess I'll just scroll back to this slide here because I think that really shows what it's like to use our system from the instructor perspective, and just leave it to as many questions as anybody has. I'd really, welcome your questions and your input and your suggestions about how to do this well.